Hello, today we're going to do section 2.2, the multiplication principle of equality, from chapter 2, equations. The multiplication principle says that if both sides of an equation are multiplied by the same number, then the result on both sides are equal in value. So mathematically what it means is that if A equals B, then AC equals BC. So as an example, we have an equation that says 1/3 x equals -6. Our goal is to get the expression in the equation in the form x equals a number so that we can solve it and figure out the value of x. So to do this, we use the fact that 1/3 times 3 is 1 and 1 times x is x. So what we do is we multiply both sides by 3. So 3 times 1/3 x equals -6 times 3. Remember that multiplication is commutative, so it doesn't matter the order that I write it. So the fact that I wrote 3 times on the first side and times 3 on the second side doesn't make a difference. But what we get is 3 times 1/3 is 1, and again 1 times x is x. And on the right, we have -6 times 3 is -18. So we get that x equals -18. As another example, we have x over 4 equals 12. So what we're going to do is we're going to multiply both sides by 4 because x over 4 is the same thing as 1/4 times x. This is something that some students tend to forget, that x divided by 4 is the same thing as 1 over 4 times x. So again, we're going to multiply both sides by 4 because 4 times 1/4 is 1, and 1 times x is x. So we make sure we multiply both sides of the equal sign by 4, and we get out that x equals 48. And don't forget that you can always double check your answers. Plug them back into the original equations. Is 48 over 4 equal to 12? Yes. We're also going to use the fact that division is really multiplication, like I just showed you. X divided by 4 is the same thing as 1/4 times x. So the multiplication principle holds true with division as well, except for the fact that you cannot divide by 0. So as another example, we have 5 times x equals 60. Again, our goal is to get it to look like x equals a number. And we know that 5 divided by 5 is 1, and therefore we can divide both sides by 5. And again, remember, this is the same thing as multiplying both sides by 1 over 5. Right? Dividing is the same as multiplying by the reciprocal. So we have 5x divided by 5 equals 60 divided by 5, which gives us x equals 12. And again, you can plug it back in. Is 5 times 12 equal to 60? Yes. As another example, we have -2x equals 14. So to get rid of that -2, we're going to use the fact that -2 divided by -2 is 1, and 1 times x is x. So we will divide both sides by -2. So -2x divided by -2 equals 14 divided by -2, which gives us x equals -7. And again, always plug it back into the original equation. Is -2 times -7 equal to 14? Yes. As another example, -x equals 20. Remember that -x is equal to -1 times x. So if we want x by itself, we multiply or divide by -1 on both sides. So -1 times -x equals -1 times 20. Or again, you could consider it as -x divided by -1 equals 20 divided by -1. Either way, you're going to get out that x equals -20. So if you ever come across a -x equaling a number, you can just move the negative sign over. What if the coefficient of x is a fraction where the numerator isn't 1, because all of our examples so far have either been an integer times x or 1 over an integer times x. And we're going to recall the fact that a over b times b over a is equal to 1. Any number times its reciprocal is equal to 1, right? You can cancel the a's and you can cancel the b's, and you're left with 1 over 1. So as an example, we have 2 over 3 times x equals 4 over 15. So what we do is we multiply both sides of the equation by the reciprocal of our coefficient of x. So you multiply both sides by 3 over 2. So again, on the left, the 3's cancel, the 2's cancel, we're left with x. And on the right, you can cancel a 2 and you can cancel a 3. So if I cancel a 2, I'm left with a 2 on top. And I can cancel a 3 and I'm left with 5 on the bottom. So we have x equals 2/5. Don't forget that when you multiply fractions, it's always faster to simplify before you multiply. Let's do a couple more examples. So 4.2 times z equals 7. Your variable doesn't have to be x. It can be anything that's not a number. So here we have an example of where it's z. What we want to do is get rid of the 4.2. So we know that 4.2 divided by 4.2 is 1. So we divide both sides by 4.2, or again, multiply both sides by 1 over 4.2. It's the same thing, so it doesn't matter how you write it. On the left, you get z, the 4.2's cancel. And on the right, if you simplify it, you'll get 5 over 3. As another example, we have 5 over 7x equals 10. And again, to get rid of the 5 over 7, we could divide both sides by 5 over 7. But dividing by a fraction is the same as multiplying by the reciprocal. So we will multiply both sides by 7 over 5. And again, on the left, the 7's and the 5's cancel, and you're left with just x. And on the right, you can cancel a 5 from the top and bottom, and you're left with 2 times 7, which is 14. Again, you can always go back and double check. Is 5 over 7 times 14 equal to 10? Yes. All right, 2 more to go. Negative 90 equals negative 54t. So to get t by itself, we can again divide both sides by negative 54. Or, again, if you want to think of it as multiplying both sides by 1 over negative 54. So you can think of it either way. And on the right, the negative 54's cancel. You're left with just t. And on the left, if you cancel it, you're left with 5 over 3. So t equals 5 over 3. And again, plug it back in and double check. Is negative 54 times 5 over 3 equal to negative 90? And our last example, negative 10 equals 4/3 y. We're going to multiply both sides, again, by the reciprocal of 4/3, which is 3/4. On the right, you're left with just y. And on the left, you can cancel a 2 in the top and bottom. And you're left with what should be negative 15 over 2. So that should be negative 15 over 2. And if I went back and double checked it, I would realize I'm missing a negative there. So that's going to be it for this section. So read over the section in the book. Let me know if you have any questions, and have a good night.